Hello. Hello. Welcome, everyone. Hi. My talk is Portal, exploring new workflows with visual tools. Let's get started. So who am I? I'm Chris. Yeah, you may have seen me on the internet as DJ Blue or on the Clojure and Slack. I've been doing software development for about 10 years. I started off doing a lot of Java and JavaScript for the first half and kind of fell in love with Scheme and wanted to start using that to build things, but I didn't quite know how to use that ecosystem, but I knew the Java and JavaScript one, so I found Clojure that way because of its great interop story. And it also gave me something I didn't know I wanted, which was immutability by default. Because I had done immutability before, but in Clojure, it's the default, which means you're not fighting the code around you or the ecosystem around you. So yeah, I've been working in Clojure professionally for the last 5 years. And of those 5 years, 4.5 of them have been working on Portal. So the goals for this talk is to give you kind of a brief intro of what Portal is. It's not really to do an in-depth UI tutorial. It's just to kind of show you different use cases of how you can leverage a visual tool like Portal. I will cover some of the UI kind of as it pops up and kind of highlight some things, but it definitely won't be a in-depth tutorial. And kind of the really big goal here is to kind of motivate you to try out some of these tools and kind of embed them in your everyday workflow so that they kind of so that they're not so much of a special thing that you bring out once in a while, but rather something you use every day. So yeah, what is Portal? It's a data visualization tool. And when I say data visualization, I mean data structure visualization, some things like maps and sets. And so another way to think about it is it's a really good place to send data that you tap from. And if you're not familiar, tap was added in Clojure 1.10, and it's kind of like console log, but for Clojure and ClojureScript, where you can kind of, instead of printing stuff to a terminal where your information kind of gets serialized and you kind of don't have any leverage, it gets sent to a visual viewer or anywhere you want. And usually it's still preserved as data. And another way to think about it is it's like standard out for tap. And if you really want to get down to like what it actually is, it's just a reagent and ring app. But the ring app is implemented for multiple runtimes. So it's implemented for the JVM, for Node, and the CLR. So you can kind of use it in plenty of contexts. OK, so I'm going to talk about like maybe for people who have used Portal, kind of maybe what your intro is or what your current workflow is if you are using it. So the idea is you pull in the API namespace and you open up an inspector, kind of like that. And you use this function called add_tap, which was added in Clojure 1.10, which is how you wire together all the things. And psubmit here is the Portal side, add_tap is the Clojure side. So you're kind of gluing them together. And then you can just start tapping things. So I'm going to click this a couple times, and it's just sending data over a Portal. And then in the Portal UI itself, you can kind of leverage all the information still being data and kind of click things. You can kind of ask the UI. Over here's the command palette, which is just a way of running functions on data, like apply fargs. It's exactly those semantics. So I can come over here and ask it, what is the type of the thing I have selected? It's a keyword. I can change viewers for things. So this is a Depps Eden map. I can come over here and select that and change the viewer from the default inspector viewer to a table viewer. And you can see it rendered as a table, right? So this is the like basics of Portal. And the nice thing about this workflow is it's very minimal, right? You kind of look at the README, you wire things together, you start tapping information, you're good to go. I think the problem here, though, is that it's good for everyone, but good for no one, if that makes sense. Like, there's nothing here that's specific about your information, right? Because we say in the Clojure community, like, everything is data, but your data has different semantics than my data. And like the tool itself can't know the difference between those semantics. Only you can know those things. And so let's look at what it looks like to kind of start customizing Portal specifically to start getting a better sense of your data. So usually, you start using Portal maybe, and then you're like, I don't like the default viewers you have set up for the data structures I'm sending you. How do I give you a default viewer? And I think that question is interesting because it's asking a bunch of different things at once. Because when you're saying you want a default viewer, you're saying I want to be able to specify via some mapping an input and an output. For this string, use this viewer. For this number, use this viewer. And so how do you represent that? You represent it as a map data structure. That's kind of a little weird. Usually those are closed sets. You can represent it as code, right? But then where does the code run? Does it run in your runtime? Does it run in the UI's runtime? Right? There's a bunch of questions that it raises. And Portal's approach is, let's just figure out a way to represent that as data instead. Like, how do you say, I want this as the default viewer? And so one way to do that, and one way that Portal has chosen, is to just represent it as metadata, right? On my data, I can say, I want to use the text viewer for strings. And then it doesn't matter where the code is or how it's written or when it runs, as long as at some point in time, that metadata got put on your value and it ended up in Portal. Now it'll know to use that default viewer as opposed to the one that's the default viewer. OK. There are some issues with that, like metadata is not supported by every value. Usually that can be solved by just wrapping the thing with the thing that supports metadata, so it's not the worst. And then there is a namespace Portal viewer that will kind of paper over a lot of the nuances of metadata. OK, so that's the solution, but how do you actually implement the solution? And so the idea, or the insight that I feel like I had was, you have add tap, and then I said to just call p-submit, which is kind of handing it off to a Portal. But there's this whole space in between where you can do whatever you want, like any type of arbitrary transformation, right? Arbitrary dispatch. And kind of, I feel like that's where there's a lot of leverage and how to customize these tools is before you hand off your data to the tool, take a look at it, put some default viewers on it, massage it in any way you want. And I'll cover kind of other things that will make more sense as we kind of see them. But OK, so for specifically this one, we're going to set up default viewers. And if you guys can read this, it's saying that if it's a string, if it matches the string predicate, use the text viewer. If it's bytes, like a byte array, use the binary viewer. Any other value, use the tree viewer. Like that's how I want to work. That's, that works for me. And so then here you can see I'm adding tap submit, where submit is no longer Portal submit. It's my intermediate submit, which is dispatching on this viewer function, and then just wrapping it. And then so then at the bottom, if I call tap, right, tap is going to put it on the tap queue, and then it's going to get called to submit, and then it's going to do all the work and then push it to Portal. And you can see here on the right that for strings, it's the text viewer. For byte arrays, it is the binary viewer. And for everything else, it's the tree viewer, right? So it's a very small, subtle thing, but I still feel like there's a lot of leverage here. And so really early on in Portal's life, I had this function called Portal API tap, which would kind of wire it together. But I very soon deprecated it because I'm like, I don't want to encourage people to use this. I want them to add their own submit functions and kind of start leveraging their knowledge with these tools. So alongside of tap were these two protocols, Datafy and Nav. You may have heard of them, you may not have. Clojure Datafy is a pretty simple protocol. It says, take in an object, return back a data representation. This is probably useful for people who do a lot of Java interop or are dealing with primitive objects as opposed to dealing with pure data. It's this is where it would be particularly useful. And so by default, Portal really early on had this enabled all the time. And I removed that because I realized that it would be better to opt in than to opt out, because maybe you want to do datafication a little bit differently, because it's only one level of datafication. So if you have an object graph, and by default you want to datafy the first 10 levels or something. I'm not sure. I don't know your use case exactly. Instead of opting out of the existing behavior and opting into the new one, you just only opt into what you want. So let's try that. And by the way, this is the opting in here. It's literally just comp, right? Take the Datafy protocol, glue it together with submit, and then that becomes your new custom submit function. So let's open that up. And then here's an example of a object in Clojure, which is the namespaces. Namespaces in Clojure are objects. They're not data. But there's a datafication protocol implemented for them. And what you'll see here is when they get datafied, they get turned into maps. And I guess we have an import map, and we have things that are interned, and you can see like all the vars in the namespace, and you can see all the publics that are exposed. And like these things are data, so these vars like have metadata, right? So sorry, what I did there is I opened up the command palette, and I'm gonna run the meta function, the meta command on this var star, and it's gonna give me all the metadata that lives on vars, right? Because when you're clicking that value, you have that value in your hand, and you can run any function on it. And again, like I was saying, if you want to do it recursively via closure walk, you can do that as well. Let's move on. Okay, so this one was a little bit not obvious to me, even though I knew about like, okay, custom submit functions are useful, I still hadn't put this piece together, which is really nice, which is if you're dealing in a runtime with a lot of promises, right? Maybe you're in Node, or maybe you're in the browser, and you're dealing with a lot of asynchronous code. Sometimes you'll like put a sometimes you'll put a print somewhere, and then you'll see that it just prints promise. And it's like, dang it, that's not useful. I'm like dealing with the complexity of debugging my asynchronous program, and I'm dealing with having to remember to add then to things that are promises, and I'm not 100% sure if they are or aren't promises. So instead of me like having that cognitive load on me all the time, let my submit function do it for me. And it can do it very easily, right? It can, in the submit function, ask if the value being submitted to it is a promise. And if it is, it can wait. This is in Clojure, but in ClojureScript you'd use .then. But in Clojure we have like the promise function, and it has a deref with a timeout. So here I can deref the promise. So let me just tap this. And if I wait long enough, here it's a 5-second timeout. It will eventually just tap timeout. Because at that point, you just don't know how long it's going to take, and maybe you do some other things. But if I tap that again, and then I deliver that promise, then you can see the value got delivered. So it's like a very nice little helper, right? This isn't a ton of code. It's a nice little helper to kind of optimize your workflow if you're dealing with a lot of promises. So, okay. In addition to Datafy, AddTap, another protocol that was added was Nav. And Nav is a little bit trickier than Datafy, but Nav is around how do you go from data to more data. I think of it as like a get in, but where you can control the dispatch, if that makes sense. So by default over here, you can kind of see if I call nav on this map. The default implementation of nav is get in, or it's just to return the value. But the cool thing is that this nav function is completely up to you and what you want to do. And Portal supports it, and a lot of other visual tools support it. So here's an example of where I'm adding nav as metadata, because that's one of the things that also got added in 110, is you can specify protocols on your data via metadata. So it's really easy to kind of opt into these protocols by just sprinkling a little bit of metadata here and there. And if I nav into this value, I'm just going to like double click it. That's how you nav in Portal. It's going to run the code of rand, which is just going to generate a random number every time. Right, that's pretty simple. I have a more intricate or more complicated example, which is like nabbing an API. So here, I'll open up the nav example I have for Hacker News, right? And so here you can see me. I have the protocol nav. It's like this var somewhere, and when I start clicking on this, it's going to start executing nav. So that called the Hacker News API. It returned this data. When you return data from nav, you can continue to decorate that data with more nav. So it kind of is a recursive expansion of data. And you can see here, like here's, I guess, something that's on Hacker News right now. And you can see at every level all the metadata that got added. And there's also other metadata too around default viewers, right? So it kind of all composes together. So that's another workflow. If you're invested in navigating trees of information, it's really easy to plug into it. And there is one more trick to nav I'll show you guys at the end that's really cool, but we'll get to that later. Okay, so more workflows. There's a test report viewer, right? So as a part of your daily work, you're probably running tests. The default test output is okay, but I wanted something a little bit, more data oriented, because a lot of my tests tend to be run code and get data, run code and get data, and then compare the data of sorts, right? A lot of my tests tend to be that way. And so I want to be able to see the data in my test as opposed to kind of having it, again, be pretty print, right? Because the default test report viewer will just take your data and output it to the terminal, right? And it's kind of just using pretty print or PRSTR. And so I was wondering, like, how do you integrate the visual workflow and the test workflow? So let's run through this workflow. I'm going to define a test. I'm going to open a portal, add a submit function. And then here's kind of the secret is when you're running your tests, you can rebind report to kind of just accumulate all the test information. And then when you're done running the test, you can just tap it out. And so if you do that, Portal has a custom viewer for it, which looks like this, which if you go to the inspector viewer, it's literally just like everything that the test reporter outputted. It's just that the default viewer will kind of roll it up and give you a quick summary at every level of what namespaces failed and what vars and what namespaces failed, and then what assertions in those var tests failed. And so you can kind of come over here and see, oh yeah, the assertion equals 1, 2 did not work, right? Because 1 is not equal to 2. Over here you can kind of see that this expression did not match, and here is a nice thing you can do is diff the value of what was expected and what happened. And here you can see the reason why they weren't equal is because 0 was removed and 10 was added. So very nice to just quickly able to diff values. And what I like about this is it's particularly nice if your values are kind of large, right? Where they're not huge, they're not this small, but they're kind of there's some stuff in the middle that you kind of want to quickly diff and you're not sure about. Okay, so those were a lot of workflows, right? They kind of had their intricacies, and you could kind of add them all manually. Some of it is available via middleware, right? When you're using nREPL, you have access to middleware, and that middleware can wrap your evaluation. And so here, I'm kind of emulating what the nREPL middleware does, but it lets you capture context when you're doing your interactive programming, so that you don't have to, all those snippets that I was showing you, you don't have to always do those. So if I evaluate this open, as you can see, it kind of captured the context. And by the way, this context here is just a map, right? What was the code that was executed, line column, namespace, the result, the runtime, all that information was captured and then automatically tapped. And then Portal grabbed it because of the add submit. So if I go back to the log viewer, we can also capture how long something took. I guess that random sleep was only 162 milliseconds. I'm just going to run through a couple more of these examples of just what evaluations would look like. So if you're printing, it will capture the standard out and standard error from your expression. That's what this is demoing. And then also additionally, like the previous slide was showing, we can capture test output automatically for you just when you run assertions. And so this is usually how I'll run my tests, is I'll have a Culva command that will say run test for this var. And then just by nature of having this middleware enabled, it will capture the output and send it to Portal. And Portal will be like, hey, I know that's test output. Let me render it as test output. And you can see that right here, right? And that's a really cool thing about here is that the viewers are kind of embedding in the same way that the data is being embedded, right? This is the same exact view I showed you on the last screen, but it's it's part of a submap. And then also exceptions. If you are running code and you happen to hit an exception, it will grab the exception and show it over here, all of the source information. And this works exceptionally well with EX data and EX info. I don't know if you guys store exceptions using EX info, but those get just shoved in here as data, and then you have the data value that you threw as data. So that is another workflow. Okay, so I keep talking about this Portal submit function, and it sounds like it's doing a lot, but I think the really funny part here is that it's not doing anything at all. It's doing code, it's executing code that is trivial. It's taking a value that you're giving it, and it's putting it into a vector. And I don't know if you've noticed, but when I tap it, it's inverse chronological. And the reason why it's doing that is because it's being conged into a list, and right, conges grow from the top. So here, if you said, I don't like that behavior, I want to customize it, I want to grow from the bottom, you can replace the submit function with one that instead builds a vector and conges stuff at the bottom of the vector. And so to showcase that, I'm going to build my custom tap list. and I'm going to add it as a submit function right here. And then when I start tapping, it will, and the really cool part here is I haven't even opened a portal yet. It's just collecting the information as it's executing. And then I opened up portal, and now it's, oh, hey, yeah, you tapped all those things and it's part of my submit function. I had been accumulating this value in the background. So it's just, the cool thing here is that portal doesn't really care about tap at all. Actually, it only cares about data and atoms, right? And that's most of the time as Clojure programs that we care, or Clojure program is what we care about. We care about the information and then a way to change it, and that's all we have, or that's all we need here. And the other thing too is you're not limited to just one instance of portal, right? You can inspect multiple values at a time, why not? So here I'm gonna just open up a completely unrelated portal. So the first one was connected to a custom vector that I had been swapping values into. This one is just opening up my deps Eden, but it's like a dedicated instance purely to my deps Eden. And so I can kind of put things, so like Portal doesn't have a way to kind of manage windows because it doesn't need it. You just open up another one. And if you're using like an editor integration, you just move your windows around in your editor. If you're using multiple OS windows, you use your OS to navigate it. Okay, so I'm gonna take all those pieces together and kind of demonstrate, I'm gonna call it the core field workflow because this is something that he came up with. Which is kind of taking all the pieces that we had like gone through and kind of being like, well, here's one complete workflow. And so you can see here, right, the signs, there's a custom submit function, it has a cond, it's calling submit, but it's also doing a custom like log atom right over here. So it's kind of like putting all these ideas together to build one workflow that makes sense for like Sean Corfield. So if I evaluate that and then I have two portal inspectors, one that's gonna be for logs and one that's gonna be for just taps. And then I can come over here and I can start logging, and what you'll see is based on the cond, right, the data, if it's a log statement, it should go to the bottom portal. Likewise, if I evaluate the last block, it will send the nREPL-based eval thing to the bottom because that's a log statement, and then it'll send taps to the top. So then what you can have is like a noisier portal that you kind of can use when you want to look into things, but it's kind of just accumulating information, and then you can just focus on your tap window most of the time. By the way, the really cool thing is, I'm gonna circle back to the command palette. The command palette is apply fargs. So if you wanna move information from one portal to the other, you have access to all the functions that you've registered with Portal, including tap. So like maybe you want to clear your logs, but you want to carry a value to your like main tap window. Well, I can just call tap and it'll lift the value via all of the code that you have set up to route your information, and then I can just clear it and then move on with whatever else I was doing to debug, right? And likewise, the inspect function that I was showcasing, like in these examples right here, you can call that from your portal. So you have a portal open and you're like, that's a cool value, I want to save it for later. Let me inspect it and then just hide it for now or do something with it later. So you can kind of like, the idea is like it's very quick to spin up and spin down. It's like no ceremony with inspecting your data. Okay, so I want to kind of showcase some of the extensibility you can do in the UI, just as like a, hey, this is cool, this is possible. And so one of the things that got built for Clerk is this thing called ME Viewers. And it was built for Clerk, but eventually got ported over for Portal because, like, right, they're both, for the most part, reagent atoms, right? It's very interoperable. You just have to glue them together. And so when you do that work of gluing to get together, you kind of can leverage like all of the NPM ecosystem to kind of pull in stuff that renders LaTeX or stuff that renders, this one will take a bit because it has to load all the NPM dependencies. And it's doing this all dynamically, right? It's like looking at your file system and pulling in all the NPM dependencies to leverage the ecosystem to kind of render, you know, to render this graph. But so the cool thing here, right, is that it is, I would say this is something I want to cover later, but it's not super easy to do this, but it is possible, right? I still think there's like some things we can do as a community to improve the shareability of some of our ClojureScript code and maybe the shareability of our dependencies, but I'll talk about more about that later. Okay, so everything so far, I've talked about is just in one runtime, right? All the routing is from one runtime into one portal, but technically, I don't know about you guys, but I work with 2 runtimes most of the time. I have a client and a server, and I don't want to have 2 portals. I just want to have one that gets all my taps. And so I can use the remote client to send taps from my client to my server and then let it host it, because it's just data. The one caveat being, right, that like the data has to transit or JSON or Edenify. You have to be able to serialize it. You can still hook in on the client side to do some transformations. Like if you wanted to massage objects or whatever, you can still do it on the client. But at the end of the day, whatever you send over the wire does have to serialize. But then you can kind of build out portals that have interlacings of client taps and server taps, and potentially even client logs and server logs to kind of just see all of the things that have happened in order, and not have to like bounce around between multiple windows to kind of get the full story of what's happening. And the clients are trivial to implement. There's a bunch of clients implemented: JVM, Node, Plank, CLR, Dart. So it should be easy to wire things up. And then if you're using Shadow CLJS, there's an automatic wiring hook to do it. So if you're using that, you just pop in this into your Shadow CLJS Eden and you're good to go. And one more last thing is I've been trying this with deployed instances, right? So if I have a client like a web browser and I deploy the code for it, I lose a lot of my tooling, right? It's like advanced compiled and like I don't have a REPL, but I can still have tap. If I open up my UI instance locally, it can tap to my local instance of Portal. And still, I can get some leverage there. Like if I want to quickly see a snapshot of the state, what we do in my company is we have this like console log function, or not a console log function. We have a global that will automatically tap values. So I just call that at the console and it will dump it to my portal. So you can kind of like orchestrate your data across multiple runtimes. Okay, so I demoed a bunch of workflows, Sean Corfield's workflow, and I want to kind of show you guys my workflow currently at my current job. And so what we do is we have this portal namespace, and it's kind of where we just put all the code I've been describing, right? We have one namespace, we kind of shove everything in there, all of our like domain-specific stuff about like, these keys mean these things, these are our default viewers, all the things go into there. And so I kind of just vendored it and put it in here because it's not particularly big and it's not particularly like complicated. And so instead of me calling Portal API open, I'm just calling our version of it that is a wrapper that's going to call that. And then we have like a data access layer. And so I'm going to like simulate getting data from our database and tapping it. And so here I've like called get entities, which is getting all these entities that we have in our database, and it's going to tap it out. And what you'll see, the first thing you'll notice, and this is kind of like another thing I've recently discovered that I think is really cool, is that because we like send data from the database client, server client in the back around, Nav doesn't make it all the way through, right? Because it doesn't serialize. VARs don't serialize. They're a runtime thing. So instead, my submit function will attach Nav for me. And so that way Nav always works. Because as soon as I have data, I can tree walk all of the data and attach Nav. So what you'll see over here is that the data I got out of the database doesn't have Nav, but the data that I have in Portal because of the custom submit function does have Nav. And we can kind of take a look at what it looks like. It's kind of big, but not too big. It's kind of just doing this big dispatch on the like keys that are being nabbed into. So we have all of these like specific keys that have specific semantics, and the like details here aren't super important, but it's like, it's very easy to like do this, to just be like, oh, I know that this key means this, so let me just write the code that lets me resolve this data when I need it. So let's execute this nav. And actually, let me go back real quick. One of the navs I wanted to point out is this one right here, which is origination ID. And so origination ID is like a group of things together that happened. And so if I navigate into the origination ID, I'll fetch all of the correlated logs, and then I'll push this graph into the metadata. So let's go take a look at what that looks like. So I'll go to origination ID, I'll navigate into that, it fetched all the data. And then if I come over here, I can kind of quickly just add a visualization so that people don't have to know about all the tooling that you have, right? Because this is something that I want for me, but I also want for my teammates so that they can kind of get leverage from all the hard work that I've done in building, the things that I built. And so it quickly adds, and you can kind of see here the picture of all this data is actually right here. It's like this thing is related to this thing by these arrows. It means, and I don't want to get into the details of what this means, because it's my domain. It's not going to mean much to you, but it means a lot to me, and it means a lot to my teammates. And the cool thing too is that if we go back to the nav function over here, the way that graph got built was it was just a function called message log to graph. Well, if I already have in my hand the data that meets that requirement, which I do, right? The first thing I did is I called get all the message logs actually. So let me just run those through the command palette, which I was talking about earlier, right? Which is right here, and I do portal message log to graph, and then here you can see more entities in our system and how they're related. So this is like a superset of the picture I showed you of all of the things, right? And so the cool thing here is you can kind of write the code and use it in multiple contexts, depending on what you have available in your current instance or what you're doing. If you're navigating through things, you're adding custom commands. So it's kind of there should be no one way to access this code. It should be whatever you want to do, it should be available. Yeah, let's move on. Okay, so this is another workflow that I've been kind of working on recently, which is for testing. And I don't love writing tests because when the code gets out of date, you have to, it's one-to-one usually if your tests are brittle, if your code's churning, or if you don't quite understand the behavior of your system yet. But what I do like doing is reading and writing data. And so one of the things I've been experimenting with in my current job is this concept of a snapshot test, which is to run the system in as high fidelity way as you want or as you can, and finding a way to datafy that as a snapshot and writing it to disk so you can check it in. And then the code changes and you rerun this snapshot. You compare the values. If they're the same, which is if you expect them to be the same, they should be the same. If they're not the same, then the thing you did changed it for a reason. Was that on purpose, right? Did you change a value somewhere that would have caused that? Did you change the computation? You don't have to think about the behavior that would have led to that to know that something did change. So it's a very quick sanity check, and this scales, so you can start in the small and just do a handful of functions. And then what we use it for at my job is we use it for our entire asynchronous worker process where we kind of get messages in and we're going through all of our business logic, and then we do side effects because of that. And so we kind of cut it off here and we cut it off here, and all the stuff in the middle is what we record and we write down. The problem though is that these snapshots can be kind of big depending on what your snapshot is. For us, it's just a serialization of our database, our database that we use during test time. So it's a completely empty one that we kind of point to our app and we say, hey, use this local instance, run the code, whatever's in the database at the end of the day, that's what we serialize, that's what we call a snapshot. And the cool thing is that the change in that snapshot should be proportional to your code change. So if you made a small code change, there should be very minimal churn in your snapshot. To me, that encourages people to minimize their code change and kind of incrementally change their system, because it lets you see what you actually did entirely. And there are caveats, right? So this doing it deterministically is difficult, right? Because we call random UUID, we call Java util date to get the current time. But once you pin those, you can hopefully, and then I guess serialize your code so that it executes in order. Then it should be easy to get this deterministic snapshot. But yeah, it's still difficult to kind of see what's happened. So here's an example of using Portal to kind of, what you'll see here is I have 2 snapshots from 2 points in time of our code base. And here you can see that there is a diff, right? And then the question becomes, is the diff intentional? You can kind of see here that this was removed, this title was changed. So it kind of highlights the details that have been changed. And now the question is, were those intentional? And if they are, you just check in your snapshot and you move on. And if they're not, then you know there's a bug. And this has caught issues for us when we've kind of been stressfully trying to fix something during a prod deploy, and we're like, oh, this is a small change, it won't break anything. So we run it, and then actually no, the snapshot test catches that the thing you thought was a small change will cause this other unintended effect. So that's one of the experimental workflows I've been trying out. And there are downsides, but there are pros, which is that the tests write themselves. Okay, and another workflow. So I said Portal was mostly around data structures. It does have charts and graphs, like it uses Vega and Vega Lite. So if you do want to throw charts and graphs at Portal because it makes sense in the context you're working in, you can still leverage those. And you're not learning anything that's specific to Portal. You're learning about these like standards and JavaScript ecosystem that are like datafying graph visualizations. So here's kind of what the visualization I built when I was benchmarking a serialization protocol. And here we go. You can kind of see all of the data as data, but you can also see it as graphs. And you can kind of see a comparison of the performance of different serialization protocols. And the cool thing is like this is still interactive in that you can like click it and it's a viewer, so I can go inspector. And this is the trick, by the way. I just put everything in metadata when I want to look at it later. If I look at the metadata, the data that's being serialized again and again is right here. So for this benchmark that's running Vega, right? It's taking that data structure that I was showing you and just calling serialize parse. And you can see all the like different dimensions of that. And these are important to me because I want to know like if it is slower, is it slower because of this type of data or that type of data? It kind of is giving me that breakdown, which made sense for what I was doing. Okay, viewer extensibility is around, I kind of showcased it a little bit with the Emmy stuff, but that was like building a viewer. Like the other thing you could do is just ship an entire ClojureScript application. And so when I first started with ClojureScript, I built this Tetris application. And I was wondering if I could run it with the SCI implementation that exists in Portal. And I was surprised. It does work, and it works really well. Like I was really surprised to be able just to take this code that's a reagent UI, right? And for the most part, just add it to my deps the like project, and it was a git deps. And then load the ClojureScript, and it works. Like I don't know the difference between this and the advanced compiled version that's deployed on GitHub. So like the possibilities are endless for what you can build in terms of like UI viewers. For this specifically, there is an REPL. So if you do want to do it interactively, Portal API REPL, you evaluate that. It'll like do the common thing with ClojureScript REPLs and like turn your current nREPL session into a ClojureScript session, so you can start evaluating ClojureScript. And I think this is cool. I have been experimenting with other ClojureScript runtimes like Bootstrap ClojureScript. I kind of have a mostly working proof of concept. Right? Maybe you wanted to ship the like much more code than SCI could handle. It'd be kind of cool to be like, okay, you run it in SCI mode for the small viewer and maybe run Bootstrap ClojureScript for this other larger viewer that's kind of doing way more work. So yeah, extensibility. I think this is where there's a lot of room for kind of making things better, both in terms of the developer ergonomics, but also like the ecosystem stuff, which I'll talk about that a little bit. Okay, so I've shown a lot of workflows. There's like a lot of things that may have just been like, that's a lot of information. You can find a lot of this information in the documentation. And if you do Portal API docs, it will open up an instance of Portal, right? Because you got to put Portal in Portal. And it will show you all of the viewers that are available. And like, well, the really nice thing that I like about the way that the viewers are structured is that each viewer has a spec that says, if you satisfy this spec, this viewer will work for you. And here's the literal spec that will be matched for exception data. And if you can satisfy this independently of where the data came from, right? If it comes from, the JVM or the CLR, like this viewer will work for it. And by the way, CLR exceptions do work for this because they datafy the same way. But yeah, you can see all the the log viewer I've demoed. There's HTTP. There's like a bunch of viewers at this point, right? And you don't need to know them all, right? Just as you need them or as you are curious, you can kind of play with them. Yeah, there's one I've been playing with recently for text diffing, because sometimes you get data as text and you kind of don't know what it is exactly. Sometimes it's HTML strings, and so you can diff text now. But yeah, I want to give a big thanks to Clojures Together. They sponsored a lot of this work for the documentation, so thank you. But yeah, so going back to my previous point a little bit, I think the biggest hurdles for this type of UI application is right, the ClojureScript downstream composition problem, I think, is still not easy to work in, right? Because if you're a Clojure program and you want to extend it, you just pull in the library and you start writing your code, you evaluate in the same runtime. With ClojureScript, it's a little different. It's a little more difficult, especially because the dependencies in the JavaScript world are not on Maven, right? They're on NPM. So there's like that is another dimension of complexity as well. So I think those are things I think moving forward should be improved, and like they've been improved little by little. But and there are other edge cases, like don't throw a lazy infinite seek at Portal. It will just blow up. It doesn't. I've tried to be smart about it, and it just, to me, it wasn't worth it because of the complexity added. So I think if you try to, it will break. But I tend not to need to do that. So, and actually, if you are dealing with a lot of infinite seeks, there is the trick, which is a custom submit function. If you're dealing with a lot of infinite seeks, your custom submit function can truncate them and then nav them to chain them together if you want to kind of like paginate the data. So you have the ability to work with infinite seeks. It's just not built in. And then there's some quirky stuff with lungs and dates that people have discovered that are just platform problems. And then, okay, there's one more thing. The lazy seeks are evaluated lazily. So even if they're not infinite, technically the internals of Portal are Clojure data structures. So if you have a map with a lazy seek as the key, and that seek has a value that blows up, the entire internals of the application are now done. So there are some protections to kind of try to realize and like weed out the exceptions. But if you throw a bad seek, not only an infinite seek, if you throw a bad seek at Portal, it might also be unhappy. So. I think I covered some of these with the extensibility. But yeah, I think the hopefully you guys are inspired by a lot of these workflows. I know some of them may have been like completely irrelevant to you, right? But they should hopefully like showcase some things that are interesting, or maybe other ways of doing things that you hadn't considered. So. Oh, actually, okay, there's one more thing. There was the Cursive talk yesterday, and he was showcasing how there's inline evaluations. I think one thing I want to try in the future is taking Portal, putting it in inline evaluations for Cursive, and kind of having both. You can have your Cursive inline evaluations and your Portal. So future ideas, crazy things. But yeah, everyone works differently. Like the problems you're working on, the domain you're working on are different. So the ability to customize your tools, I think, is super important. And you've seen a bunch of ways how you can customize it to kind of fit your needs. I think that's it. Thanks, everybody. The slides will be available here. I just need to make it public. But you can, the entire presentation is an interactive thing you can go through if you want to play with it yourself. So.